Okay, so the first problem says, what is the value of this? What is the value of 11 factorial minus 10 factorial 9 factorial? Okay. You can just factor out a 10 factorial. And then 11 minus 1 over 9 factorial. So that is 10 factorial times 10 over 9 factorial. That is, okay, 10 factorial is 10 times 9 factorial, right? So I can do this. This cancels out with that. I get 100. So the answer is B. Okay. Okay, so moving on to question 2. Question 2 says, problem 2 says, for what value of x does 10 to the x times 100 to the 2x is equal to 1,000 to the 5th power? Okay, so I'll just get everything in terms of 10 to the... Okay, so that's 10 to the x times 10 squared to the 2x is equal to 10 cubed to the 5th power, right? So that is x plus 4x using these rules equals 15, right? So x equals 3. So our answer is C. Okay. Okay, moving on to question 3. Remainder can be defined for all real numbers x and y by this greater, less than or equal to x over y. What is the value of this? Okay, so I can just substitute in values for x is equal to 3/8 and y is equal to negative 2/5. So I get that 3/8 minus negative 2/5 and then 3/8 over negative 2/5. Okay, I get this, right? So first of all, I'm going to try to simplify this. So I can do that 3/8. Okay, I'm trying to 3/8 times 5/2. So I can flip these, right? And there's a negative here as well. That is negative 15 over 16. So I'm trying to find the greatest integer less than or equal to x over y. In this case, the greatest integer less than or equal to negative 15 over 16 is just negative 1. So this whole thing comes out to be negative 1. So I get that 3/8 plus 2/5. You also have to account for these negatives over here times negative 1. You have to account for this negative, right? And so I will erase this now. So I have some space. And I get that 3/8 minus 2/5 is going to be my final answer. But I have to simplify this even more. So that's times 8 times 8. Times 5 times 5. That is 15 minus 16 is negative 1. 5 times 8 is just 40. So my answer is B. My final answer is B. Okay, moving on to question 4, problem 4. Mean, median, and mode are equal to x. What's the value of x? Okay, so I know that I have 7 values. And I have a sum here. Oops, sorry. Sum is equal to... So the mean, median, and mode are equal to x. So this is all equal to x. Okay, so I can find the sum of all these. 60 plus 100 is 160, 200, 250, 450, 540 plus x. This is just 540 plus x. I get that 540 plus x, and I can cross multiply now to get equals 7x, and I get minus x, so 6x equals 540, and x equals 90. That's my final answer. Remember, look at what the question's asking you. If it's asking for the value of x, in this case, the answer would just be D. But the question could ask you for other sorts of answers, like what is the value of 2x, what is the value of 3x. It can ask you anything, so you always got to make sure you look at what the problem's asking you. Okay, problem 5. This states that every even integer greater than 2 can be written as a sum of two prime numbers. Would be the counterexample. Okay, so if this states that even integer has to be the sum of two prime numbers, then the counterexample would just be an even integer that cannot be written as a sum of two prime numbers, which I think would be, yeah, wouldn't that just be E? I think that's E, because greater than 2 but cannot be written as a sum of two prime numbers. So yeah, I think it should be E. Yeah, I think it's E. Yeah, because even integer greater than 2 has to be written, so if it cannot be written, that's a counter. Yeah, I think it's C. Okay, number 6. Triangular array of 2016 coins has 1 coin in the first row. Okay. 2 in the second row. Okay, I'll use different colors for this. And 3 in the third row. And then we go up till n. Okay. So 4 in the fourth row, for example, 5 in the fifth row, 6 in the sixth row, and so on until n. And I'm trying to find the sum of the digits. Okay, so a cool formula that you should know is n times n plus 1 over 2. And this gives you the sum of the first n positive integers. Okay, so I can say that this is equal to 2016 because that's my sum, right? That's the sum of the first n positive integers. So I'm trying to find out n first, right? I'm trying to find what n is so I can find the sum of the digits of n. So I get that n times n plus 1 is equal to 4032. Okay, this is basically just, okay, this is n squared plus, I can just say that this is n squared, right? Because plus 1, yeah, I can just make this n squared, so I can basically find the square root of this whole thing, and then I can just find like values like 1 plus 1 from that or minus 1 from that, and like that, because this is really close to n squared basically, because n plus 1, like I just need to find like the square root of this thing, and then I can easily find like what n is. So that's what I'm gonna do. So I can erase all of this, and then I basically, so I had that n times n plus 1 is equal to 4032. Okay, so I know that, I think that 60 okay, 60 times 60 is 3600, right? So 6 times 6 is 36. 70 times 70 is 4900, so I'll just write those things down. Okay, so we know these, right? We know this is true and this is true. And this number is sort of in the between, but it's leaning more towards 60. That means that it's probably like lower than 65. I think that it's lower than 65. I'm going to go with trying to do 63, because it has to be two consecutive values, right? So if it's lower than 65, I would say 64 and 63. Let's try those, yeah. It could be 65 too, I'm not sure, but I think it's lower than 65. Yeah, I think it's either 62 or 63 or 63 and 64. Let's try 63 and 64 first, just to see what happens. I'll use a different color for this. Okay, this is 2, 1, 25, 0, 8, 1, oops, 137, 2. This is 3, 1, 4. Wait, what? Wait, I'll do that again. I'll have to do that again. Okay. I think I made a mistake there because that's, yeah, I think I made a mistake. Okay. So that's 2, 1. Okay. This is 25. Okay, that's good. And then I add a 0, 8. This is 8. This is 137. Okay. So I think now it should be right. 0, 1. Yeah. Okay. Okay. So I get 4032, so I'm right. So this is correct. 63 is equal to n. But this is not my answer. The answer is asking, the question is asking for the sum of the digits. 6 plus 3 is 9. Oops. So 63 equals n. And then 6 plus 3 is equal to 9. So yeah, I made an error here, so I'm sorry about that. Made an error here, but after fixing it, I got the right thing, which is 4032. So yeah, my answer, it's D. Okay. Okay. Problem 7. Yeah, problem 7. Okay. So problem 7 states, which of these describes the graph of x squared times x plus y plus 1 times is equal to y squared times x plus y plus 1. Okay, can I just not divide by x plus y plus 1? Yeah, I think I can do that. So I get that x is equal to plus minus y, right? Oh, wait, x plus y plus 1 can also equal 0, so that would also work, right? Okay, so I have x plus y plus 1 equals 0. And then, okay, so y is equal to negative 1 minus x, right? Okay, so I got this and I got this. I think that's it. Yeah, I think that's it. Okay, so this I got it from, because x squared is equal to, x squared equals y squared, right? So I can just take the square root, and then I got this. And then basically for this, if I plot it, it's going to be kind of like that. Oops, sorry. Okay, this is... Oh, I'll use a different color for the other one. Yeah, okay. And then... negative 1 minus x, right? So that would probably be somewhere over here. Right? Negative 1. Yeah. Yeah. Oh, sorry. I think I messed this up. Okay, so negative 1. Oh, okay. Negative 1 is here. Wait, what? Okay, negative 1 is here. And then negative x. Okay, this should be like that. Something like that. Okay, my drawing is not the best, but it should be something like that, because negative 1 and then... Yeah, okay. So I get three different lines. So, 3 lines are all positive. 3 lines that all pass through a common point. I think it should be D, because it says, yeah, these all don't pass through the same point. Oh, yeah, these all don't pass through the same point, so like it has to be D. Okay, moving on. So okay, moving on. We get, what is the area of the shaded region? Okay, I will sketch this. I'll try my best to sketch this figure over here. So then I have something like this. Okay, and then something like this. Okay. This is a 171471114. Okay, obviously this drawing is not the best, but like I think it's pretty decent. Like I think it gives a good approximation of this over here. And then I can shade this in. So I'm trying to find out this yellow portion, right? It says area of the shaded region. Okay. So what I can do here is, okay, so I know the area of the whole thing is 40. So I can say that of the entire, I can just erase that. Okay. Okay, we just know that the area is 40 of the whole thing. So we know that, okay. Okay, and then what I can do is I can sort of make like a little triangle over here, connecting to the center, and join this here. Okay, so this area and this area should both be the same, right? I mean, that's pretty self-explanatory. I think, yeah, this area and this area should be the same, because we have a 4, we have the same height, and then it's a triangle. So the height is okay, wait, so the height is, okay, so this is 4. Oh, okay, so this is going to be half of 4. This should be 4 as well, right? Because this whole thing is 8. This is half because this is at the midpoint. Yeah, this is at the midpoint, so this should be 4. So that means the area of each of these is 4 times 4 is 16, divided by 2 is 8. So this is 8. That means this is also 8. And we'll do the same thing here. So find the area of this triangle and this triangle. So I get that this triangle is 1/2 times 7 times this height, which is half of 5, so 2.5. So 5 halves times 1/2 times 7, which is 5 4 times 7 is 5. Wait, think I made a mistake. Oh no, okay, never mind. 5 4 times 7, which is just 35 4. So that is for this one and this one. Okay, so we have the 4 things. So what we can do is add these up. 40 minus the sum of all these, and we get the area of the shaded region. Okay, we'll do that. So all we need to do is 40 minus, and then add all of these. So 16, because 8 plus 8 is 16, plus 2 times 35 over 4. That's 1, that's 2. So 16 plus 17.5 is, I can just do, or I can just do it like 40 minus, okay, 40 minus 16 minus 35 halves. I'll just do that. I get 24 minus 17.5, which is just, that is 6.5. Okay, so it should be D. Oops. Okay, I think it's D, because all I did was I got the areas of these 4, this whole thing, and then this, like, basically the white space is here. And then I just got the area of the whole figure, subtracted like this, and then I got the area of the shaded region, which I think is 6.5. So that's D. Okay. Moving on to problem 9. Okay, problem 9 says that 5 shaded regions are 5 small shaded squares inside this unit square. Okay, it says unit square. It means this is 1, this is 1. Okay. Congruent and have disjoint interiors. Okay, I'll draw the whole thing again just to see. Just to visualize it a little better. So okay, then I get one like that, one like, oops, it's not very good. Okay, and then I have a little square thingy. I want, oops. Okay, this is obviously not the best drawing, but I think it's, yeah, again, I think it captures like the, like it captures the image pretty well. This is all shaded in. I'm just gonna shade in like a part of it. Yeah, just like that. Okay. Common side length is a minus root 2 over b. A and b are positive integers. What's the a plus b? Okay, so I'm trying to get my side length in terms of this. Okay, so it's a unit. It's a unit inside this unit square. So let's just say that these have lengths of let's call it y. This is also, because each square is congruent, so that means each square, we're just gonna assume that y is like the side length of like each square, right? So this is y, this is y, this is y, this is y, this is y. Okay, we'll just assume that for now. So we'll focus on this square for now. So that means that this whole thing is gonna be y root 2, right? This is y root 2, then this would be this is the center of the square. This should be the center of the square. I don't think it looks like that, but it should be center. This should be s over 2. Okay. And I know that this whole length is 1, right? Because it's a unit square. Okay. So what I can do is 2 times... Okay, I'll scroll down a little bit. So I can do 2 times... Okay, so what I'm trying to do is add both of these, right? I can do the same thing, like connect this to like this part. So this is s over 2 and this is oh sorry, this should be y. I don't know, it says s. I think I just put s for like side length, but like it should be y, because we assume that the side length of each square is y, right? So okay, this should be y over 2. Okay, so this is also, okay, this is y over 2, so that means, okay, so this is why I think I should use blue for better visualization. This is y over 2, so that means this is also y over 2, because this whole thing is y, right? This is y over 2, this is y over 2. Essentially what I'm doing is I'm doing 2 times y root 2, because this is y root 2 and this is also y root 2, plus s over 2. Oops, sorry. This should be y. Is equal to, okay, so if this whole thing is 1 and this whole thing is 1, that means this whole thing is 1 root 2, which is just root 2. Okay, great. Okay, so we get that. Just 2 root 2 y plus y is equal to root 2, right? I can just take out the y. So y 2 root 2 plus 1 is equal to root 2 divided by the root 2 plus 1 on both sides. And I get that y is equal to wait, did I do something wrong over here? Root 2. Okay. I think it's right. So what I'm trying to do here, okay, I'll just multiply both sides by root 2. I think that's, oop, that does not look like a square root sign. There should be a root 2, and this is multiplying by root 2. Okay, root 2 times the root 2 is just 2. Okay, yeah, 2 times. Okay, I think, okay, this should be, okay, so root 2 times this whole thing. So 2 times 2 is 4 plus root 2. Okay, So okay, I'll just multiply by 4 minus root 2 now. I think I messed up a step or something because this is taking way too long. I don't think it's supposed to take this long, but okay, but whatever. I'll just do it this way. So I get that 8 minus 2 root 2 over 16 minus plus, so 16 minus 2. This is 8 minus 2 root 2 over 14. Divide everything by 2, I get that 4 over 7 and then minus root 2, right? Isn't that what it should be? Divided by 2, 4. Yeah, I think that's it. Okay. What's the question asking for? Okay, great. So we got it in this form now, okay? It's fully simplified. It's in this form. Basically, what I'm trying to find is a plus b. So 4 plus 7 equals 11. E. Okay, we're done with that. Okay, that does not look like an E. Okay, E. Great. Okay, let's erase all of this. Okay, so we will be moving on to the last problem for today. 5 friends sat in a movie theater in a row containing 5 seats, numbered 1 to 5 from left to right. Okay, so we got 5 seats. 1, 2. Okay, 1, 2, 3, 4, 5. Actually, I think I should like space them out evenly. So 1, 2, 3, 4, 5. Okay. So okay, so Ada went to the lobby to get some popcorn when she returned that. Okay, so Bia moved 2 seats to the right. Okay, 2 seats to the right. TC had moved 1 seat to the left. So 1 seat to the left. D and E just switch spots, leaving an N seat. Okay, that's very important. So N seat. So either this seat or this seat remain for Ada when she gets back. Okay. In which seat has had Ada been sitting before she got up? Okay. Okay. So let's do some trial and error. So if Ada was sitting here, let's say if Ada was sitting here, and C was here. Okay, let's just abbreviate all these. So Bia will just say B. CC we can just say C. D we can just say D, and then Eddie we can just say E. Okay, so let's try this first. A C E B D. Initially, let's say it's this, right? So B moved. Oh wait, it can't be that. Yeah, it can't be that, right? Yeah, I don't think it can be that. Okay, so B A C E D, because then B can move 2 spots. Because okay, Ada's gone, so Ada's gone. So that means we have B. This is gone. C, E, and D. So that means that C can move here. B moves here. These 2 switch spots, and Ada is left with the first spot. Right? Okay, that works. That works. Okay. Yeah, I think that works because B, A, C, E, D. If they're sitting in here initially, right? Okay, I'll just erase all of this to provide more clarity. So if this is the thingy, if this, I mean, sorry, if this is, these are the seats before, that means that, because, okay, these 2 switch. This one moves 1 here, because this seat is gone. This seat is gone, okay? And then this one moves here. That means that it's going to be C, B, D, E. So this spot is empty for Ada, and this is an N seat. So that means that before she got up, she was sitting in the second seat, and this is through trial and error. So second seat is the answer. B is the answer. So I hope that makes sense. If there are any problems or any if there are any problems or any mistakes or any yeah, if there are any mistakes with any of the problems that I did, please let me know. Thank you.